Welcome to Grade 10 Chemistry. This video was produced by E. Fanos. My name is Jessica and I'll be your instructor for this unit. Unit 4, Chemistry in Industry and Environmental Pollution. In this video, we'll be going over Subunit 4.4, Some Industries in Ethiopia. By the end of this subunit, you should be able to define industry, list some industries in Ethiopia, describe the general characteristics of industries, and outline the important steps in productions of ceramics, mention some uses of ceramics, and outline the important steps in production of cement, as well as outline the important steps in production for sugar. Furthermore, you should be able to outline important steps in the production of pulp and paper and explain how tanning is carried out, while describing the application of chemical preservation of skins and hides, and mention some uses of these skins and hides. You should also be able to explain the process of food packing and preservation, and present a report to the class after visiting a nearby food factory. We'll begin by talking about glass. Glass is an amorphous or non-crystalline solid material. It contains silica as the main component, and quartz glass is made by melting pure silica at a temperature of about 2300 degrees Celsius. It is of high strength, low thermal expansion, and highly transparent. Soda lime glass is ordinary glass, which is a mixture of sodium silicate and calcium silicate. The following reactions take place in the formation of soda lime glass. Here we can see sodium carbonate and calcium carbonate combining with silicon dioxide to form silicates and carbon dioxide gas. Soda lime glass is used for window panes, bottles, and dishes, and accounts for about 90% of all manufactured glass. Borosilicate glass is commonly known as Pyrex, and you may be familiar with it from different laboratory settings. It is manufactured using boron-3 oxide. It has a high resistance to chemical corrosion and temperature changes, and it's used to make ovenwares and laboratory glasswares such as flasks, beakers, and test tubes. We'll now go through the process of making glass. To start, we have the preparation of the raw materials, where we have 20% sodium carbonate and 19% limestone. From there, the materials are heated to a temperature of around 1600 degrees Celsius. The glass is then formed and made into the required shape. We now go to the annealing step, which involves the removal of internal stresses by reheating the glass followed by a slow cooling. Finally, we inspect and test the glass product and pack and dispatch it to be distributed. Moving forward, we'll talk about ceramics. Ceramics are inorganic, non-metallic solids prepared by the action of heat and subsequent cooling. Traditional ceramics include porcelain tiles and pottery produced from minerals such as clay, talc, and feldspar. Industrial ceramics are produced from things like silicon carbide, alumina barium, titanate, and titanium carbide. The raw materials to make ceramics are dug out of the earth. They are then crushed and ground into a fine powder. This powder is then purified by mixing it in the solution and allowing a chemical precipitate to form. Processes of manufacturing ceramics include molding, where small amounts of wax are added to the purified powder to bind the ceramic powder and to make it more workable, or plastics can be added to the powder to give it a desired pliability and softness. The powder with additives can then be shaped into different objects by various molding processes. Following this, they can undergo the process of densification, which uses intense heat to condense a ceramic object into a strong, dense product. After being molded, the ceramic object is heated in an electric furnace to temperatures between 1,000 and 1,700 degrees Celsius. Ceramics are in general hard and wear resistant, brittle, refractory, thermal and electrical insulators with non-magnetic and oxidation resistant while being chemically stable. There are many uses for ceramics. Some well-known uses of ceramics include art sculptures, dishes, platters, kitchenware, and kitchen tiles, while lesser-known uses include electrical insulators, computer parts, or dental replacements, and also tiles in the displacement, the part of a roof that displaces water. Some future uses of ceramics include removing impurities from drinking water and replacing diseased heart valves. The third material that we'll review is cement. Cement, or ordinary Portland cement, is an important building material made of calcium and aluminum silicates with gypsum that hardens into a stone-like mass. Cement mainly consists of calcium silicate, calcium aluminate, iron 3 oxide, and magnesium oxide. It's made through the process of calcination, or heating to a high temperature in the presence of air or oxygen. Here we can see a schematic for the manufacturing of cement, and we'll go into each of these steps individually. First, we have the material preparation. Limestone and clay are crushed separately. Then the materials are mixed at the correct proportions. The combined materials are then crushed together in either a wet or dry process, with the dry process being preferable because it consumes less energy. In the upper part of the kiln, the raw materials are heated to completely remove moisture. In the middle part of the kiln, limestone decomposes to calcium oxide in this reaction seen here. By the lower end of the kiln, the temperature reaches 1,600 degrees Celsius and the mixture reacts to form the following calcium aluminates and silicates. At this point, the mixture is referred to cement clinker. In the finishing step, the clinker is cooled and is mixed with 2 to 3% gypsum and ground into a fine powder. The final composition of cement is around 50 to 60% calcium oxide, 20 to 25% silica, 5 to 10% alumina, 2 to 3% magnesium oxide, 1 to 2% ferric oxide, and 1 to 2% sulfur trioxide. Cement is a highly versatile and useful building material. When mixed with water, cement first forms a plastic mass that hardens after some time. Hardening occurs through the formation of crosslinks, also known as chemical bonds, between different chains in the material. In the hardening of cement, the transition from plastic to solid state is called setting. The first setting occurs within 24 hours and takes 2 weeks to fully harden. We'll now go into sugar manufacturing. Sugar canes are gathered by a combination of manual and mechanical methods. The leaves are removed and the tops are trimmed off. From there, the stalks are thoroughly washed and a machine with rotating knives shreds the cane into fibers. Hot water is sprayed on the sugar cane to dissolve the remaining hard sugar. The shredded sugarcane then travels through a series of heavy-duty rollers. From there, the juice will be extracted, and the pulp that remains is dried and used for fuel. The juice is then added to a mixture of carbon dioxide and milk of lime to clarify it, and in this process, it is heated until it boils. The carbon dioxide forms calcium carbonate and attracts non-sugar debris. From there, the clear juice boils at a low temperature and the water evaporates, forming a thick brown syrup. Once thick enough, crystals begin to form and the remaining mixture is sent to a centrifuge and dried. The dried sugar product is raw sugar, which is edible. Raw sugar is then transported to the cane sugar refinery for the removal of molasses, which gives it its brown color, minerals, and other non-sugars that contaminate it. Sulfur dioxide is used to remove the color in the water, and this is the bleaching step. From there, the crystals are separated by their different sizes, and small and large crystals are packaged and labeled as white refined sugar. We now move on to paper and pulp manufacturing. In this process, the raw material of wood is used to make paper pulp, which is a dry, fibrous material. Wood pulp is made from softwood trees, such as spruce, pine, fir, larch, and hemlock, or hardwoods such as eucalyptus, aspen, and birch. Wood is composed of the proteins cellulose, lignin, as well as oils and resins. To begin the industrial process, trees are harvested and transported to the industry. The bark of the tree is removed and the wood is chipped into uniform size. Pulping is the process in which wood pulp is made from the chipped wood pieces. There are two types of pulping methods. Mechanical pulping involves steam, pressure, and high temperature to tear fibers. And the end products from this pulping method are typically used in products such as newspapers. Chemical pulping combines wood chips and chemicals in large vessels called digesters. We'll now go over two different methods of chemical pulping, beginning with the Kraft process. This process uses a basic digestion medium, consisting of sodium hydroxide and sodium sulfide. After digestion of about 4 hours at a temperature of 170 degrees, the pulp is separated by filtration. The second process is called the sulfite process. This process uses a digestion medium containing a solution of sodium bisulfate or magnesium bisulfate at a pH of about 3, making it an acidic digestion medium. Again, the pulp is recovered by filtration. We will now talk about tanning. Tanning is the process of converting raw animal hides and skin into leather using tannin. Leather is a durable and flexible material created by the tanning of animal hides and skin. Tannin is an acidic chemical that permanently alters the protein structure of skin so it can never return to rawhide or skin again. The tanning process begins with a number of preparatory stages. Curing is the salting or drying of the hide once it has been removed from the animal, and it is employed to prevent putrefaction and remove excess water. Brine curing is the simplest and fastest method. From there, the hides are soaked in water for several hours to days to remove salt, dirt, debris, blood, and excess fat. After the soaking process, hides are moved through a machine that strips the flesh from the surface of the hide. Hair removal, or liming, is the process in which hides are immersed in large vats containing lime and water. After 1 to 10 days, the hide is run through a hair removing machine. Scudding is the removal of remaining hair and fat using a plastic tool or dull knife. Finally, the skins undergo a de-liming process where the remaining lime is removed in a vat of acid. There are 2 different methods for tanning. Vegetable or natural tanning involves the skins being placed in a solution of tannin derived from barks and trees from many different plants, some of which are listed here. The resulting leather is flexible and is often used for making shoes, luggage, and furniture. The second method is mineral tanning. This process has the skins placed in a solution of chemicals such as chromium sulfite and salts of chromium for as short as 24 hours. The process imparts a greenish-blue color to the skins because of the chromium. The process also produces stretchable leather used for making garments and handbags. After the leather is tanned, it can go through the crusting process. In this process, the leather is dyed, rolling can be used to make the leather stronger, and it can be stretched in a heat-controlled room. Finally, the leather is coated with waxes and oils as well as glazes to make it more appealing. Finally, we'll go over the food processing industry. Food preservation is the process of treating and handling food to stop or greatly reduce spoilage, loss of quality, edibility, or nutritive value caused or accelerated by microorganisms. It stops the growth of bacteria, fungi, and other microorganisms. And it will also reduce the oxidation of fats, which causes rancidity. Some modern methods of food preservation include freezing, which is the most used process both commercially and domestically, freeze drying, in which water sublimates as water vapor instead of evaporating to dry the product. This allows the product to maintain its original shape, taste, and color better. Finally, we have vacuum packing, which stores food in an airtight bag or bottle, and the vacuum removes oxygen and stops bacterial growth. In summary, glass is a mixture of 2 or more silicates. Pyrex is a glass containing boron. It resists high temperatures. Ceramics are materials that are baked or fired in very high temperatures. Cement is made by heating a ground mixture of sand and clay. It also contains calcium oxide, silicon dioxide, aluminum oxide, iron 3 oxide, and magnesium oxide. Sugar is manufactured from sugarcane in a series of steps. Paper and pulp are manufactured from trees in a series of steps. Bleaching agents such as chlorine, chlorine oxide, ozone, or hydrogen peroxide are used in paper and pulp production. Tanning is a process of converting skin to leather. The methods used in food processing and preservation are salting, pickling, sugaring, smoking, drying, and canning. Review question 1. What is the basic difference in the composition of glass and cement? Glass is a combination of 2 or more silicates, while cement contains silicates and aluminates. These compounds facilitate the cross-linking that allows cement to harden. Question 2. What is ceramics? Ceramics are inorganic, non-metallic solids prepared by the action of heat and subsequent cooling. Question 3. Write the main chemical equations involved in the production of cement. These are the main equations involved in the production of cement: the formation of silicates and aluminates. Question 4. Describe the refinery process involved in sugar production. In the refinery process, molasses and minerals are removed and bleaching agents are used. Question 5. Explain the difference between chemical and mechanical pulping. In chemical pulping, chemicals, either basic or acidic, are used to digest wood chips into wood pulp. Mechanical pulping involves high temperature, pressure, and steam to break down the wood chips. Question 6. How does natural tanning differ from mineral tanning? Natural tanning uses tannin derived from plants and trees, while mineral tanning uses chemical compounds such as chromium salts. Question 7. Point out the modern methods of food preservation. Modern methods include freeze drying and vacuum sealing. This concludes subunit 4.4. Thank you.